Have you ever wondered what the end of the world actually looks like? Not in movies or nightmares, but in crushing, suffocating reality. Can you imagine standing on solid ground while beneath your feet, the planet tears itself apart from the inside, while fissures split open like wounds that stretch beyond every horizon? What would it feel like to watch lava fountains rise higher than clouds, painting the sky orange for 1,000 miles? To breathe air that burns your lungs while acid rain dissolves the leaves from dying trees? Have you ever considered that we walk on a planet that once murdered almost everything living on its surface? That beneath Siberia's frozen forests lie the scars of Earth's greatest act of self-destruction? If journeys through deep time bring you the same fascination they bring me, if you find awe in Earth's most catastrophic moments, please consider liking and subscribing. Share this with someone who needs perspective on what a real planetary crisis looks like. I'd love to know where you're listening from today. What corner of our healing Earth do you call home? Leave a comment below and tell me, what other catastrophes from deep time should we explore together? But now, prepare yourself for the ultimate catastrophe. Welcome, brave soul. I am the Chrononaut, your guide through time's most terrible moments. Today, I take you to witness something that defies comprehension. A million-year volcanic eruption that nearly ended the story of life itself. Prepare to witness the Siberian Traps, Earth's greatest killing machine, the event that defines what extinction truly means. Come, let us descend into Earth's darkest hour. We arrived 252 million years ago, at the end of the Permian period. But I will not start with the eruptions. First, you must see what we're about to lose. This is not the dead world you might expect. This is Earth at the height of its Paleozoic glory. Forests of tree ferns stretch to every horizon, their fronds catching moisture from daily rains. Seed ferns, those evolutionary experiments that would give rise to all flowering plants, carpet the understory in emerald abundance. The rulers of this world are not dinosaurs. They haven't evolved yet. Instead, meet the therapsids, the mammal-like reptiles that dominated every ecological niche. Gorgonopsids, saber-toothed predators the size of bears, stalk through the undergrowth. Their prey, the massive herbivorous dicynodonts, browse in herds that shake the ground with their passing. In the seas, life has achieved staggering diversity. Coral reefs stretch for thousands of miles, but these aren't the corals you know. These are rugose and tabulate corals, creating underwater cities of forms that seem almost alien. Among them swim the last of the trilobites, those ancient arthropods that have survived every previous extinction. Ammonoids spiral through the water in shells of mathematical perfection. Brachiopods carpet the seafloor in numbers that defy counting. The atmosphere itself is different. Oxygen levels are lower than your time, but still abundant enough to support large, active animals. The climate is warm, stable, predictable. Pangaea, the supercontinent, stretches from pole to pole, its interior a vast desert, but its coast teeming with life. This is a successful planet. Life has recovered from previous extinctions and achieved new heights of complexity and beauty. There are no signs of impending doom, no warnings that everything is about to change. But deep beneath what will become Siberia, something stirs. The first signs are subtle. In what is now the Tunguska Basin, animals become restless. They can feel vibrations through their feet that no human instrument could detect. Deep in the earth, at the boundary between crust and mantle, a plume of superheated rock has been rising for millions of years. It's finally reached the surface layers. The ground begins to bulge. slowly at first, just millimeters per year. But across an area the size of Europe, those millimeters add up. Rivers change course as the land tilts. Lakes drain in one place and form in others. The tree ferns that have grown straight for centuries now lean at odd angles. Then come the earthquakes. Not the sharp, sudden quakes caused by shifting plates, but deep, rolling tremors that last for hours. The ground moves like ocean swells, solid rock behaving like water. Trees fall not from the violence of shaking, but from the disorientation of earth that won't stay still. In caves throughout the region, bats flee in daylight. Snakes emerge from winter hibernation months early. Birds abandon their nesting grounds in massive flocks that darken the sky. The animals know what the rocks are trying to say. Run. But there's nowhere to run on a supercontinent, and what's coming will find you wherever you hide. The eruption begins not with a mountain exploding, but with the ground simply opening. A fissure appears, running perfectly straight for 50 kilometers. At first, it's just a crack, maybe a meter wide. Steam hisses from its depths. The rocks on either side glow dull red from heat. Then the crack widens. 5 meters, 10, 20. And from this wound in the earth comes something that defies description. Lava doesn't flow from the fissure, it fountains. Jets of molten rock shoot 2 kilometers into the sky, sustained not for minutes, but for days. The roar is beyond sound. It's a physical force that pulverizes trees 50 kilometers away. The ground shakes not from earthquakes, but from the sheer violence of planet blood hemorrhaging from the wound. This isn't like the volcanic eruptions in your time. This is flood basalt volcanism, a phenomenon so extreme that Earth has only experienced it a handful of times. The lava emerges at temperatures exceeding 1,200 degrees Celsius, hot enough to flash boil any water it touches, hot enough to ignite forests dozens of kilometers from the actual lava. But the lava is just the beginning. With it comes gas, sulfur dioxide in quantities that stagger comprehension. In the first days of eruption, more sulfur enters the atmosphere than all of your civilization's pollution combined. It combines with water vapor to form sulfuric acid. The first acid rain begins falling within hours, stripping leaves from trees, turning lakes into vinegar, beginning the slow dissolution of life. Carbon dioxide emerges in volumes that transform the atmosphere. Not the gradual increase your climate scientists fear, but a sudden injection that raises global temperatures by degrees in decades rather than centuries. The greenhouse effect kicks into overdrive. And then there's the really nasty stuff. Hydrogen sulfide, the rotten egg gas that's toxic at parts per million. Methyl chloride and methyl bromide that rise to the stratosphere and begin dismantling the ozone layer. Toxic metals vaporize by the heat, mercury, lead, arsenic, that will rain down across the globe. Let me take you to ground zero, though no living thing could actually witness this and survive. The main fissure has widened to a canyon 50 meters across. The lava fountains merge into a continuous curtain of fire that stretches to the horizon in both directions. The heat is so intense that the air itself glows orange for kilometers around. The lava spreads outward in all directions, moving not like water, but like a living thing. It's so fluid, so hot, that it flows faster than a human can run. The leading edge advances at 20 kilometers per hour, a wall of molten rock 5 meters high that consumes everything in its path. But consumes is the wrong word. Things aren't burned by this lava. They're erased. Trees don't catch fire. They flash into vapor. Animals don't die. They cease to exist. their very molecules torn apart by temperatures that shouldn't exist on Earth's surface. The ground itself melts, adding to the growing flood of liquid rock. Within the first week, an area the size of Britain is buried under lava. But this isn't a single flow that cools and stops. The eruption continues. New fissures open parallel to the first, then perpendicular. Soon, a network of bleeding cracks turns the landscape into a hellish chessboard, each square flooding with fresh lava. The lava flows reach rivers and lakes, and the results defy imagination. Water doesn't just boil. It explodes into steam with such violence that it shatters the lava into microscopic glass particles. These glass shards, lighter than ash, rise into the atmosphere on the steam columns. They'll circle the globe for years, tiny knives that shred lung tissue with every breath. I need you to understand the scale. In your time, a large volcanic eruption might produce a cubic kilometer of lava. The Siberian Traps will produce 4 million cubic kilometers. If you stacked all this lava on New York City, it would reach halfway to the moon. But the volume alone doesn't capture the horror. This eruption doesn't happen once. It happens thousands of times over 1 million years. Just as life begins to recover from one eruptive phase, another begins. Evolution tries to adapt, but the rules keep changing faster than DNA can respond. The first great dying happens within decades of the initial eruption. It starts in the forests around the volcanic province. The acid rain is relentless. Trees that survived previous challenges watch their leaves dissolve, their bark peel away, their roots burn in soil turned toxic. The great seed fern forests, Earth's first experiment with advanced plant life, collapse into rotting mats of vegetation. Without plants, the herbivores starve. The magnificent herds of dicynodonts, those tusked browsers that fill the ecological role of your elephants and cattle, waste away. Mothers abandon calves they can't feed. The herd split into smaller groups, then families, then lone individuals wandering a dead landscape until they too fall. The predators last a little longer, feeding on the corpses. But there are so many corpses that even the most efficient scavengers can't process them all. Bodies rot where they fall, releasing methane that adds to the greenhouse gases. The gorgonopsids, those supreme predators, find themselves in a world where their prey is already dead and rotting. They turn on each other, and then they too begin the slow slide to extinction. But the real catastrophe happens in the oceans. Let me take you beneath the waves to witness murder on a scale that numbs the mind. The seas absorb carbon dioxide from the atmosphere, turning the water acidic. Not slightly acidic. We're talking about pH levels that dissolve calcium carbonate. Every creature with a shell, every coral polyp, every microscopic form that builds its house from the sea's minerals, finds itself in water that unmakes its very existence. Watch a coral reef die. It doesn't happen quickly. First, the polyps retract, stressed by the changing chemistry. The symbiotic algae that give coral its color flee or die, leaving behind white skeletons. But even these skeletons begin to dissolve. The reef becomes a ghost of itself, then crumbles into rubble, then dissolves entirely. Thousands of species that depend on the reef, fish, crustaceans, mollusks, lose their homes, their food sources, their very reason for being. The trilobites, those ultimate survivors that weathered 300 million years of changes, finally meet their match. Their chitinous exoskeletons can't form properly in the acidic water. Eggs fail to develop. Larvae die before molting. The last trilobite dies not in some dramatic moment, but simply fails to reproduce, ending a lineage older than trees. In the deep oceans, the changes are even more profound. The water becomes stratified, layered like a cake with no mixing between levels. The bottom layers lose all oxygen. Bacteria that thrive in oxygen-free environments explode in population, producing hydrogen sulfide in quantities that turn the deep sea into a toxic soup. This purple, stinking water gradually expands upward, pushing oxygen-breathing life into an ever-shrinking surface layer. Now the eruptions enter a new phase. The initial fissure eruptions were just the opening act. The magma chamber beneath Siberia is so vast that as it empties, the ground above collapses. Calderas form, not the neat circular calderas of normal volcanoes, but irregular pits dozens of kilometers across. These calderas immediately fill with new lava, but now the eruption style changes. Instead of fountaining, the lava bubbles and froths, releasing even more gas. The sulfur dioxide emissions increase tenfold. The stratosphere turns opaque with sulfate aerosols, reflecting sunlight back to space. Here's where the true horror becomes apparent. The volcanic winter from the sulfur should cool the planet, but the CO2 greenhouse effect is stronger. The result is chaos, wild temperature swings, decade-long winters followed by centuries of hellish heat. Life can't adapt to conditions that change faster than generations pass. On land, the last forests are dying. Not the dramatic death of fire, but the slow death of starvation. With sunlight blocked, photosynthesis fails. Plants yellow, wither, collapse into mulch. The soil itself dies as the bacteria and fungi that cycle nutrients succumb to acid and heat. The herbivores are long gone. The carnivores have turned to cannibalism and then to starvation. But some life persists in the margins. Small burrowing animals, the ancestors of mammals, hide underground, where temperatures are stable and some moisture remains. Insects adapt faster than vertebrates, their short generations allowing rapid evolution. Some plants produce seeds that can survive decades, waiting for conditions that might never come. In the oceans, the survivors cluster near the surface, in the thin oxygenated layer that remains. But even here, death stalks them. The purple hydrogen sulfide water continues its inexorable rise. When it breaks the surface, it releases gas that kills anything that breathes it. Coastal areas become death zones where nothing can survive. 500,000 years have passed since the first eruption. You'd think the Earth would start recovering, but the Siberian Traps are just getting started. A new phase begins. Explosive eruptions that make everything previous seem gentle. The magma, rising through the crust, encounters huge deposits of coal and oil-bearing rocks laid down during the Carboniferous. When 1,000-degree magma meets fossil fuels, the results are apocalyptic. The coal doesn't just burn, it explodes, sending billions of tons of carbon into the atmosphere in massive detonations that can be heard on the other side of Pangaea. Worse, the oil and gas deposits turn into natural chemical weapons. The heat breaks down complex hydrocarbons into toxic compounds: benzene, toluene, formaldehyde. The air becomes not just hot and acidic, but actively poisonous. Breathing means death, but not breathing means death too. The explosions excavate vast craters, throwing debris into the stratosphere. But this isn't normal volcanic ash. It's mixed with burning coal, vaporized toxic metals, and hydrocarbon aerosols. When it falls back to Earth, it brings concentrated poison that sterilizes the soil for centuries. Global temperatures have now risen by 10 degrees Celsius. The polar ice caps, which provided climate stability, have completely melted. Sea levels rise by hundreds of meters, drowning coastal lowlands, where the last refuges of life clustered. But the rising seas are purple, acidic, and toxic. They bring not relief, but another avenue of death. Let me show you what Earth looks like after 750,000 years of eruption. From space, you wouldn't recognize your home. The blue marble is gone, replaced by a brown and grey sphere shrouded in perpetual haze. The continents are still there, but they're lifeless as the moon. Siberia is unrecognizable, buried under 4 kilometers of basalt that extends from the Arctic Ocean to what will become Mongolia. An area larger than Europe has been paved over by successive lava flows, creating a monument to destruction that will last until the continents themselves are recycled. Where forests once stood, only bare rock remains. The soil is gone, not just the topsoil, but the very concept of soil. Without plants to create it and organisms to maintain it, the land has reverted to sterile mineral surface. Rain still falls, but it's acid rain that carves channels in the rock without bringing life. The oceans are alien. The surface waters are green with sulfur bacteria, the only photosynthetic organisms that thrive in this new chemistry. Below, the purple layer of hydrogen sulfide has claimed 90% of the ocean's volume. The sea floor is carpeted with black ooze, the remains of everything that died and couldn't decay in the oxygen-free water. But look closer, and you'll see something remarkable. Life persists. In isolated pockets where local conditions allow, organisms scratch out existence. Some hot springs maintain chemistry that allows ancient bacteria to survive. In the polar regions, where temperatures are merely tropical instead of infernal, some fungi endure. And deep in burrows, a few tetrapods, 4-legged vertebrates, hang on by the slimmest of margins. The eruptions finally begin to wane after 1 million years, not because the magma is exhausted, but because the plume has burned through the crust and established equilibrium. The lava still flows, but at a rate the Earth can begin to process. The gas emissions drop from catastrophic to merely severe. But the planet that emerges from this million-year trauma is fundamentally changed. 96% of marine species are gone. Not just extinct, but erased so thoroughly that many left no fossils at all. Entire branches of the tree of life have been pruned away. On land, 70% of vertebrate species have vanished. The great Therapsid dynasty is ended. The Gorgonopsids are extinct. Most of the Dicynodonts are gone. The complex forest ecosystems have collapsed to simple communities of opportunistic survivors. But in this devastation lie seeds of the future. The few surviving therapsids include a lineage that will become mammals, small, nocturnal, burrowing creatures that survived by hiding from the apocalypse above. One specific survivor, Lystrosaurus, will briefly become the most abundant vertebrate on Earth, occupying 90% of available niches simply because nothing else is left to compete. The oceans slowly begin to mix again as temperature gradients re-establish. Oxygen creeps back into the depths, pushing the purple hydrogen sulfide layer down and eventually eliminating it. The acid levels drop as volcanic CO2 emissions slow and rock weathering accelerates. Life, reduced to its simplest forms, begins the long climb back to complexity. It will take 10 million years for ecosystems to fully recover. When they do, the world will be utterly different. The Permian fauna, refined by hundreds of millions of years of evolution, is gone forever. In its place, new experiments begin. A minor group of reptiles called archosaurs will radiate into the empty world, eventually producing crocodiles, pterosaurs and dinosaurs. In the seas, new types of corals will build reefs on the dissolved foundations of their predecessors. Ammonoids, reduced to a handful of species, will explode into thousands of new forms. Bony fish, minor players in Permian seas, will inherit the oceans. The Siberian Traps created what paleontologists call a reset, a near-complete erasure of evolutionary history that allowed entirely new directions to be explored. Without this catastrophe, mammals might have remained forever in the shadow of therapsids. Dinosaurs might never have evolved. Your own existence required this near death of the planet. But what caused it? Why did the Earth try to kill its own children? The answer lies in plate tectonics and terrible timing. The Siberian Traps erupted through the Tunguska Basin, which contained vast deposits of coal, oil, salt, and other evaporates. The magma didn't just bring lava. It mobilized billions of tons of buried carbon and toxic compounds. It was like setting fire to a chemical weapons depot the size of a continent. The plume itself rose from the core mantle boundary, possibly triggered by the subduction of oceanic slabs that accumulated at that depth. When enough cold, dense material collects at the boundary, it can displace the hot mantle, creating an upwelling that rises as a coherent mass. This isn't rare. It's happened throughout Earth's history, but rarely does it hit such a perfectly wrong place at such a perfectly wrong time. Stand with me now on the cooled lava fields of Siberia, a 250 million years after the eruptions ended. In your time, these basalts are hidden under forests and tundra, but they're still there. A 4-kilometer thick scar that will last until the continents themselves are destroyed. The Putarana Plateau in northern Siberia, those spectacular flat-topped mountains cut by deep canyons, those are the Siberian Traps. Every layer in those canyon walls represents a separate eruption, a separate pulse in Earth's million-year fever. You can read the history of the extinction in the rock. Black basalt interleaved with red oxidized layers where centuries passed between flows. Core samples drilled through these rocks tell the story in exquisite detail. The chemistry of each layer records the gases released, the temperatures reached, the speed of cooling. Tiny bubbles trapped in the basalt preserve samples of Permian atmosphere. Microscopic crystals record the exact conditions of crystallization. It's all there, waiting to be read by those who know the language of stones. Modern volcanoes seem almost quaint in comparison. Your largest eruptions, Tambora, Krakatoa, Pinatubo, wouldn't register as blips during the Siberian Traps event. Even Yellowstone, the supervolcano that keeps your disaster planners awake, would need to erupt continuously for 1,000 years to match just the first phase of the Siberian eruptions. But here's what should truly terrify you. It can happen again. The conditions that created the Siberian Traps aren't unique to the Permian. Right now, plumes rise from the deep mantle beneath Hawaii, Yellowstone, Iceland. Most will never cause flood basalt eruptions. Most. The Deccan Traps in India erupted 66 million years ago, contributing to the extinction of the dinosaurs. The Columbia River basalts in North America erupted just 17 million years ago. The Ontong Java Plateau formed underwater 120 million years ago, causing ocean anoxia and mass extinction. Earth has this weapon in its arsenal and uses it irregularly but inevitably. Your civilization exists in a brief quiet period between catastrophes. The fact that no flood basalt eruption has happened in human history doesn't mean they've stopped. It means you've been lucky. Geological processes don't care about human timescales. Climate scientists worry about raising global temperatures by 2 degrees. The Siberian Traps raise them by 10. Environmental scientists fear ocean acidification dropping pH by 0.1 units. The Permian saw drops of 0.5 units or more. Your worst-case scenarios are starting conditions for what Earth can do when it really tries. Yet life survived. That's the other lesson of the Siberian Traps. Despite the most thorough attempt at sterilization the planet has ever made, life endured. In the deepest catastrophe lie the seeds of renewal. The few become many. The simple becomes complex. The survivors inherit an empty world and fill it with new possibilities. Every living thing on your planet descends from survivors of the Siberian Traps. The disaster is written in your DNA. The genetic bottlenecks, the borrowed adaptations, the jury-rigged solutions that got your ancestors through the crisis. You exist because life is harder to kill than planets are to break. So when you face your own challenges, remember the Siberian Traps. Remember that your ancestors survived the death of almost everything. Remember that from the worst catastrophe came the innovations that made you possible. The planet has been broken before and healed. Life has been pushed to the brink and returned stronger. The black basalts of Siberia aren't just rocks. They're monuments to both death and survival. They record the worst thing that ever happened to life on Earth. But you're here, reading this, which means they also record life's greatest victory. The Earth tried to kill everything. It failed. You are the proof. Until we meet again in the deep past, this is the Chrononaut, reminding you that you walk on a planet capable of unimaginable violence, and you are descended from those who survived its worst. The Siberian Traps are still there, waiting under the snow. Sometimes, when conditions are right, gases still seep from deep fractures. The wound has healed, but the scars remain. And deep in the mantle, new plumes rise, counting time in millions of years, preparing Earth's next great convulsion. Sleep well.